here to talk to you today about adopting APIs and microservices and the journey we've taken down that road. Note that it says part 2. This is really a follow-up to a presentation I did at the last Nordic event in Stockholm in October of last year. And I hope my good friends at Nordic will forgive me the indiscretion of tagging a part 2. They didn't know I was going to do that, but I didn't want to represent the exact same presentation for a couple of reasons. First of all, it's up on YouTube. You can go watch the first presentation anytime you want. So I didn't think having 2 of exactly the same presentation on YouTube would be helpful. And second, a bunch has happened since then on our journey, and I wanted to make sure you were getting the most relevant, most up-to-date information. So with that, I think we got enough bums in seats now. Let's begin. I'm going to talk about our journey adopting APIs and microservices at CIBC. The first thing you will hear at a large organization when you are socializing APIs is APIs are nothing new. They've been around since the 70s. They've been around since software has been around. Why are you making such a big deal out of it? Whoever's saying that is right. That's absolutely true. APIs have been around since software has been around. It stands for Application Programming Interface, and it simply refers to the way that software speaks to other software. So of course it's been around since software's been around. But back then, if you look at the picture on the far left, you'll see monolithic applications. These represent big, proprietary, honking applications. Back then, sometimes they were on mainframes that filled entire buildings, and you would speak to these things however you could speak to them. Whatever interface they provided you, that was how you would speak to them. This was the beginning of digitization. Banks were on this journey. They were moving paper into these giant mainframes. And the fact that all these interfaces were proprietary and brittle didn't really bother them because, wow, they have no more paper. They moved to computers. That was pretty great. And this worked well for a while. But then it started to get unwieldy. Too many interfaces, too many systems, too costly to maintain. They're breaking all the time. How do I manage this? The term spaghetti came onto the scene. People said, how do I manage the spaghetti? The first run of solutions that tried to solve this problem were called ERP, Enterprise Resource Planning Solutions. They basically said, take all your stuff, put it in our proprietary set of building blocks, and we'll solve your spaghetti. Didn't really work. Even more expensive, even more proprietary, even harder to manage. And now a vendor is getting all the checks. So along comes EAI, Enterprise Application Integration, and says, oh, this is a little better. We're kind of sort of standardized around some sort of framework, but it's still super proprietary. They basically said, take all your spaghetti, put it in our big spaghetti bowl, and now you can manage it inside our big spaghetti bowl. But still spaghetti, still expensive, still proprietary. Didn't really work. And along comes Service-Oriented Architecture, SOA, and the notion of an enterprise service bus. And for the first time, the industry has a way to define API contracts based on standards, like SOAP and XML. Before SOA, that didn't exist. You developed only proprietary API interfaces. The idea of a standard, industry standard-based contract was a revolutionary idea that SOA introduced. They also introduced the notion of an enterprise service bus, which would act as a kind of router and broker in between your consumers and providers of these web services, as they were called. And things were pretty good for a while. Wow, you could actually do consumers and providers developing in parallel based on a contract. Pretty amazing. But then that ESB thing started to get fatter and bigger and do stuff, logic stuff. It started to look a lot like what those EAI things were doing. That's not what an ESB is supposed to do. It's supposed to be a router and a transformer. It's not supposed to do semantics. And you get into these arguments about semantics versus syntax and what logic goes in the bus. And it's a mess. You've got your spaghetti problem again. So what happened? In our case, a lot of folks did this. They took their SOA environment and they federated it. They said, hey, lines of business who want to do crazy business logic, like adding trailing zeros or running conditional statements, here's your own little local service bus. We called it a domain service bus, a DSB. And as long as you make sure that your domain service bus hooks into the main service bus using standard stuff and follow certain rules, we're good. Federated SOA, we called it. Worked pretty good for a while. Have our cake and eat it too, right? They can do their own thing. We've got a nice clean bus in the middle based on data power, I should mention, which turned out to be a great choice, lightweight, purpose-built. But then something else happened. My visual aid, this happened, right, on this side of the room. When this showed up, everything changed. Suddenly people could order a taxi, a hotel room, a pizza, with a couple of taps on their phone. And consumers expected exactly the same kind of interaction from everyone they do business with, probably most of all the banks. So this created a fascinating and very rapid dynamic where folks wanted to get to the App Store very, very quickly. API providers who powered those apps would release strong APIs because they're vying for that market share from those app providers. Suddenly the app providers take advantage of new APIs, and you see this acceleration of development cycles where suddenly you don't just want a great API, but you want it to be better and faster and newer the next day. And you get to things like daily releases, and that drives breaking down the monolith into these constituent little parts that come to be called microservices. I'll talk about those a little more later, but everything changed. Now, while, as the diagram illustrates, this is a natural evolution of integration from the monolithic app to SOA to increasing distribution to ultimately APIs and microservices, there is something that changed radically. One of the other speakers spoke about this as well, and that's the focus. SOA was all about reusability. It was all about cost rationalization, saving money. This new thing, REST, JSON, modern APIs, whatever you want to call it, is about speed. It's about innovation. It's about getting to market ahead of your competitors. That is a fundamentally different driver than what we were trying to achieve with SOA. And if it's about speed and innovation, which ultimately means competition, then that represents a big cultural shift for the bank, and you have to make sure that you build those kinds of shifts on the right technology. So how do we build it? What did we do? Well, we went out to vendors. That's what banks do. We default to a buy posture, and we go and talk to analysts. We got a lot of money. We'll buy stuff. And I spoke to the analysts, and I spoke to consultants, and I said, who's the leader? Give me the Gartner Magic Quadrant. I'm going to buy someone in the corner of the Gartner Magic Quadrant. And it turns out there were no leaders. The analysts would either, if they were good analysts, wouldn't give you a name at all because they would admit there are no leaders, or they'd give you a name because they're bad analysts, and they'd give you different names. And if they did give you a name and you came back to the same person a couple of months later, he'd give you a different name. So volatile, highly volatile. Even with the marching orders from senior leadership to say, you know what, narrow the search to open source first, cloud native. Usually when these kinds of paradigm shifts are happening, open source is where it's at. So we did. And even in open source, we found while there were some nice kind of stakes in the ground, generally also highly volatile, no real leaders. So what do you do in an environment like that? We took a bold approach. We decided to make an exception in the case of our buy posture and build something. We found an open source core called the Light framework, the Light platform, brought the owner of that open source project in-house, built a team around him, and developed an in-house API platform that we call the API Foundation. We weren't content to take the developer's word that the API Foundation was good. Never do that, never believe that a developer says his own software is good. And we gave it to all those same analysts. We even found a company called Nordic, who you may have heard of, to take a look at it. And they came back with almost unanimous analysis. They said, your documentation kind of sucks. We're not entirely sure why you would do this, but wow, this thing that you've built is pretty amazing. It's a pretty amazing piece of kit. They beat it up, they put it in labs, Red Hat put it in their lab and tested it at scale, and it seems like what we had built stood up. All the same, why would a bank like ours take a build posture? Well, how could you justify taking an exception in this case? Well, really there's three main reasons. One, as I've mentioned, it's a good hedge against a highly volatile market. Even if the dust settles in a few years and a leader emerges, that's fine. You can shift to the leader in a few years, but you're biding your time, because right now there is a lot of dust kicked up in the air. The second reason, the second reason is you can steer the direction of the framework. So this is huge for us, because sometimes we want to do things that aren't very high on vendors' priority lists. An example is GraphQL. We needed to build an interface that supported GraphQL because of the nature of the use case we were solving. No vendor out there has commercial support for GraphQL that we could find, so we built it. We went to our team and said, build us a GraphQL interface, and they did. We now support GraphQL in our platform. And the third reason, perhaps the most important, is it develops critical internal skills. By developing an internal team that are experts at this, you're going to learn about Swagger, you're going to learn about OAS, you're going to learn about developing microservices, DevOps, daily releases, automated testing, automated deployment, automated scaling. All of those skills are portable. It doesn't matter if tomorrow you decide to shift from a build to a buy and adopt some new solution. You're going to need to know all those things. The die is cast. Those things are happening. So developing those internal skills is critical, and I would argue becoming even more critical, and I'll talk about that a little bit more later. Establish your guiding principles before you pick your technology. I talk about this at length in part 1 of this talk. I would encourage you to go to YouTube and check out my rambling about this particular subject. But to be perfectly honest, I need the time back. So I'm not going to spend a lot of time on this slide, but I will say, don't be surprised if, as you're establishing your principles, you're dealing with things that seem to be at odds with each other, like proliferation of APIs on the one hand, and standardization and governance on the other. This is normal, hence the illustration of the scale. Don't shy away from those kinds of debates. They are valid. Chances are the right principle is somewhere in the middle. So what did we build? It might be easier to explain what we didn't build. Okay, we did not build a magical black box. What do I mean by magical black box? Well, a lot of the vendors who we were talking to around the beginning of last year sold an API gateway. Now, API gateway is a bit of a polluted term. If you go out there and do your research, you'll find that API gateway means different things to different people. MuleSoft calls himself an API gateway, but Nginx is also an API gateway. But they're two radically different things that do very different jobs. We found that a lot of the vendors, in particular the large ones, especially if they had just acquired somebody, were selling something closer to the MuleSoft variety, which is to say, a magic box, you plug everything into it, it's going to do all the routing, translation, business logic, everything that you might want the thing to do, and just deal with all the complexity. Does this sound familiar? It should. This is a repackaging of SOA done poorly, of the ESBs done poorly, of EAI, and of ERP. All of them are magic black box solutions, and none of them ever work. I've been in this industry for about 25 years and never seen that work. It always hits a wall. So what did we do? What did we do that was different? Well, we took a distributed gateway approach. What does that mean? Well, it embraces an architectural style known as microservices. Now, microservices, I apologize to the earlier speaker, are the secret sauce. APIs are not the secret sauce. Microservices are the secret sauce. Let me illustrate by example. Let's say you have a mainframe, and on that mainframe you have 10 functions, and you want to expose those 10 functions as APIs. Well, I could grab one of those magical black boxes and create the most beautiful, wonderful GraphQL, gRPC, JSON, RESTful OAS APIs you ever saw on top of that mainframe. They would be wonderful, modern, fit all of the criteria of the developer experience. And developers would love them. You would genuinely get an enormous advantage on the consumption side. Developers could read the APIs, use them more easily, integrate with the back end more easily. But then that developer will say, add a field. Or that developer will say, what if on that one function, number 10, I need to hit it like 1,000 times more than I thought I needed to hit it because it's Black Friday or something? What do? You're stuck. You can only move as fast as your mainframe can move. So you're going to say to that developer, wait 6 months. And they're going to leave. And they're not going to like their API experience at all. So what happened? The problem was not the APIs. The problem was your monolithic implementation underneath the APIs. And that's what microservices aim to solve. They solve that by breaking down the monolith into a set of small parts that run individually, essentially as tiny applications communicating with each other through APIs. If your goal is speed, and I would argue that most people who are on this API journey, their goal is speed, then microservices are your secret sauce, not APIs. If you're doing APIs with microservices, I promise you, you will hit a wall. What does that mean for gateways? Well, we implemented a distributed gateway approach. What that means is we embed a tiny gateway into each individual microservice. We did not invent this idea, thank God, because we're not Google. And this is not that architecturally dissimilar from what you might find from Spring Boot or from Drop Wizard or other folks who've implemented a pattern known as a microservice chassis. It essentially means that inside the microservice, you have all the cross-cutting concerns that you would normally get from a centralized authority. Logging, metrics, heartbeat, security, all fully distributed, all fully cloud native, portable, atomic. Means I can pick up any one of these microservices from Azure, put it in AWS, everything it needs is still there. I have no dependency on anything being implemented from one cloud provider to the other, and each one of these pieces can be independently upgraded, monitored and operated, and scaled. Truly distributed architecture. Now, does that mean there's no place for gateways? No, there's probably still a place for API gateways at the perimeter to control certain zones and stuff. But we think that internal service-to-service communication is better handled in a distributed way. And you know what? The industry agrees with us. The distributed approach is taking hold. We've seen this over the last couple of years, especially in the time since I've presented, the distributed approach maturing to something known as the service mesh. Now, as you might imagine, I have to defend our architecture a lot. I get a lot of emails from folks at CIBC saying, gateway, gateway, gateway. And I freak out. How am I going to defend this? And then I look at the dates on the articles that they've sent me. And it makes me feel better. Because all the articles that talk about how great gateways are come from 2013 to 2015, really heavy on the 2015. Then around 16, 17, now especially 18, it all kind of goes away. Everybody starts talking about this whole service mesh thing and how amazing it is. The vendors follow suit, one vendor after another. IBM has moved to this strong loop micro gateway in their API Connect strategy. CA has repackaged their gateway as a micro gateway. Kong supports a service mesh distribution model. Google is moving to something called Google Endpoints, and more recently, Istio, their service mesh framework that is still in beta. And the new pure plays, Istio, Open Contrail, Conduit, Linkerd, these guys are pure mesh. They don't even have the notion of a gateway. So something is happening here. With the rise of the service mesh, I would argue that the volatility is not getting better, it's getting worse. More sand is being kicked up into the air, not less. That makes development of internal skills even more critical. Let me demonstrate by example. We've built this API foundation in-house. Not only do we feel validated by the movement of the industry towards service mesh, we think that because of our internal skill set and building a team around this, we have not only implemented a service mesh, but we've built what we call a service mesh plus. For example, standard service mesh uses a sidecar pattern where you have a dedicated microservice running alongside the resource you're trying to integrate into the mesh. We've implemented an embedded gateway, so you don't actually have to run a separate container. The gateway is embedded right into your code, optionally, right? If you don't want to touch your code, you don't have to, but we have a way to embed it right into your code, saving you a hop and making your whole mesh even faster. Other service meshes require a homogeneous mesh, where everyone who's participating in the mesh is running the same mesh, so you can't really have Istio and Linkerd running together. We've implemented a collection of light proxies and routers that really don't care. You can use as much of API Foundation or as little as you want, and we play fine with other meshes. Using Jenkins today in a service mesh, it's limited to building a single microservice at a time, so you either have to write your own scripts or jump through a bunch of hoops to basically recompile an entire mesh of services. We've extended Jenkins with an extension called Lightbot that allows you to build multiple microservices together at once, all at the same time. And finally, on the OAuth side, all the OAuth servers out there, the good ones, will offer you fully distributed authorization, which is great. We're trying to take that a step further and implement federated authorization, which is a trust network across a collection of OAuth servers. And Travis in the back is going to help me do it. So all this to say, you don't have to understand what I mean by all these things. What you do have to understand is that doing APIs and microservices the right way forces you to act more like a technology company. And that's really the critical skill here. Treat your assets more like products. Behave more like the technology incumbents, especially for banks. That is critical. I was nice in my footer when I said critical shift to get it right. Jamie Dimon from JP Morgan recently said Silicon Valley is coming. He's referring to the coming Uberization of the banks. So if I was a little meaner in that footer, I would say it is a critical shift for a bank to survive. So how are we doing? The API Foundation is now in full swing across the bank. These are real milestones. They're not hypothetical milestones like I presented last October. The API Foundation core is being used across the bank. We have a governance council in place. The APIs are mandated. You have to use it or come up with a good reason why not. We have a managed container as a service environment, which is to say Kubernetes, on a private cloud built with our technology partners. We have a development one now in place. By the end of this month, we'll have a full production one with all of the distributed cross-cutting concerns built in. So the logging, the metrics, the security built into our CAS as utilities. Ongoing developer training. I can't stress this enough. If you are going to embark on a program, make sure you have an adjacent developer training program so that you can make sure your groups are seeding the knowledge, you're finding your development champions, and spreading the word as you go. Invite feedback. You're trying to build an internal community around your platform. And finally, we have a pilot of our internal marketplace running today. If you were on the CIBC network, you could go to marketplace.cibc.com and see a dev portal, which will allow developers to seamlessly be able to publish new APIs and consume existing APIs without having a single meeting, without having a single phone call, and without sitting down and developing some sort of mapping document. Self-serve, powerful stuff. It's really from that self-serve model that we realize our cost savings. Although we don't have a ton of data, we've only deployed a few of these. Early data would suggest a significant cost savings, 50 to 70% per integration that we're trying to build between two systems. What tips can I give you if you're at a bank trying to do this? Well, you've got a bunch of different pillars at play, and you have to acknowledge that all of these things are happening at once, but they have a very strong interdependence. I've spoken about APIs, but you've also got your cloud strategy, your DevOps strategy, and your agile strategy. All of these are interrelated. If one of them is falling short, it's going to be dragging down the other three. So you have to make sure your organization understands that all of these have to run in lockstep. If one of them is down, it's going to drag your whole strategy down. You have to keep them balanced. Even more tricky than that is building the foundation on which these pillars rest. You've got your technology and operations, but that's only one part of it. Under that, you've got your organizational structure, which has to often be revisited. Again, if your goal is speed, you probably want something like vertically integrated teams, etc. But frankly, that's not really anything to do with APIs. You have to go to the folks who are deciding how your organization is structured and have a heart-to-heart with them about how to change that. And then finally, probably the most challenging of all is an organization's culture. Especially at a bank, they're typically not built for change. They're typically not built for innovation. They're built for safety and trust. So to be able to go to them and shift that culture towards a mindset that a technology company has about being an innovator, about riding that bleeding edge, that can often be the biggest challenge of all. I'll leave you with what I think is the single most important idea you have to remember as not just banking, but the whole industry goes through this paradigm shift, because make no mistake, that's what it is. I don't say that flippantly or facetiously. It is a paradigm shift. Is that the way we are thinking of IT systems is changing. The analogies are changing. From the 70s up until pretty recently, we thought of IT systems as being like buildings or cities. They are fixed, rigid things. You have to get the spec right up front. If you don't, the bridge will collapse. That's changing. Thanks to a lot of the groundwork laid by, well, the internet, the cloud, all the supportive technologies that sit on top of them, the capacity that we have at our fingertips today, things like this. The analogy is changing. IT systems are increasingly thought of as living systems. The analogies you now hear are molecules and cells, biological analogies that come from the world of complex, adaptive, open systems. What all those analogies come down to is we have to think of how to build systems that are built to change, built to evolve. Rather than built on fixed, rigid standards, they're built from the ground up to expect change and to incorporate it easily. Systems that can elegantly and incrementally adapt to this change never have to be replaced. They only have to evolve. Thank you.